Hello everyone, I am Hiroki, and my presentation is titled as Automated Distributed Testing using TTCN 3. I used the automated distributed in the title, but contents focus on what is TTCN 3 and how to use on the FreeBSD. And URL on the top of the slide is shown all the time during the presentation. So if you are interested in reading the slide, please download the PDF file. So the outline of my talk is listed on this slide. First, I am a FreeBSD committer for a long time, over 25 years right now, and working on the various field. And I'm a coaching member and a docking team member as of today. And I will talk about the testing framework, and including the current FreeBSD project, the testing framework briefly, because what is the advantage or disadvantage of the TTCN testing framework? To understand that we need to compare, or we need to understand the current framework. And then I will talk about the TTCN 3 as in the presentation title. Okay, the first topic is testing of FreeBSD, not the testing on FreeBSD. FreeBSD has its own automated testing suite under user test, as you know. And results of the user tests are available not only for developers, but also for the users, because testing is also useful for the end users. And the source files of the user tests are under the user source tests, and the package-specific directories like user source bin ls tests. And all of the test cases, the scenario is organized using the Kyua framework, and details are explained in the manual page tests, section 7. And basically, you can try the test framework, the test suite, by installing QR utility using a package command, and then QR utility, run the QR utility with the options such as the tests and specifying the QR file under user test. This command will do every single testing scenarios available under user test. So it takes a long time, and the results will be stored under your home directory by default, .qr directory, and the database is created under that directory. And the contents is not human readable, so if you want to get the human readable output, you need to evoke the QR report subcommand like this. So the reason why the user test available also for the users is the user can use the testing scenario to double check the behavior of the fresh installation of FreeBSD. But as a project, we are using this testing framework, of course, for development aid to detect unexpected bugs with regressions. So providing the officially maintained automated test suites is essential for quality assurance in the project. So this is why the testing suite is inside the base system. So let's move on to the topic of the testing framework we are using. QR is the testing framework name. It is developed by NetBSD developer Julio. Probably Julio is around here because he is on the speaker list this year's BSD Can. But it is a GSOC project, one of the GSOC project results. And after that, QR is evolved much And FreeBSD started to use the QR and library part, the ATF, extensively to build up the testing framework, testing scenarios. But more generally speaking, the testing framework like QR, what we are using consists of test cases and test case description capability, usually written in some kind of programming language, and the test case runtime framework. It may be just a command, or it may be some system, and the reporting capability. So these three parts are generally considered as a testing framework. And the QR is a runtime part and reporting part. So QR directly is not directly connected to the concept of test case description. And for that, we are using the C program or C++ or shell script or that kind of program language we can use. And writing the test scenario in a programming language, then the scenarios are invoked in the operating system. The QR will handle the invocation part and collecting the report from the invocation of the binaries. And so QR is neutral in terms of the description part, and basically supporting the TAP, the test anything protocol outputs, and ATF library. So this is a simple example of test anything protocol. It's when the test anything protocol is used. This is a simplified version of the testing cases for the test command, basic Unix command. And the output of the test scenario is something like this. And this output format is specified as test anything protocol. And the header is number of test scenario, in this case, the 1 to 8. And then an OK or not OK is listed. Simple lines. So the running the test, if everything is working as designed, all of the scenarios result OK. And the second column is just a testing scenario number. So running a test, and QR will pick up this output as a result, and all of this scenario passed, the result will be just marked as success. And QR has a configuration file called the QR file here. And in the example in the previous slide, the QR test, and this file is specified as an argument. And inside the QR file, and what kind of test scenario is must be run by QR, and what protocol is used to report back to QR system. And the top test program means the legacy test is the file name of the program. It is just a shell script. And the legacy test is invoked. Then the output is fed to QR, and the protocol is interpreted. The output is interpreted as syntax of the TAP, test anything protocol. But in the case of the library, it is difficult to run the library directly on the command line. So we need some commands or some binary that uses library to export the internal state or results to where the QR can look into it. So for LibM, tests are under user source lib some tests, and not the number test.c, you can see, and it has a lot of lines inside the file, but the test number test and function you can find, and you can see some keywords, some macros from prefixed by the ATF something. So these macros are used for testing, so connecting the binary to a Kyua system. So in this case, a test anything protocol is not used because so formatting the OK or not OK output using the main function is it is not impossible technically, but it is a common part for every functions in this library if you want to test every function. So to minimize the burden, so ATF library is used. So ATF library can minimize that label as part of creating the test scenarios. So ATF-TC head or ATF-TC without head, this line define the test case NAN, not a number. And the target of the test is not the number F. So F means a float. That's return value, return type. And this test NAN accepts the string expression of the number. So this string is tested by the actual function, and result will be reported back to Kyua using the ATF require. And ATF require means the expression in the argument is evaluated as whether true or false, and it must be true if the test succeeds. So is NAN means the argument AF0 is not a number or not, and if not a number, the return value is true, and it means the test passes. And the actual argument is listed on the ATF-TC body. This is a macro, but expanded to functions used in the test cases. And the test NAN 0x1234. This is not a number or not. And so how about the empty string? So these argument and what is expected results are totally depending on the what do you want to test. But in a C program, you can use the ATF library and the macros to define the test cases in our framework. And the Kyua file is simpler than the C program. Not at the top, the ATF test program is defined here. The Kyua will pick up the NAN test binary and receive the results in the way of the ATF library. So what is the problem of our testing framework? In short, there is no problem. So I do not intend to blame the current testing framework structure or trying to replace them with other one. But then the testing framework is working well and probably simple to understand for developers, even for users. But there are challenges in general for the testing framework. It is there is no exception even for our testing framework. So I summarized the challenges into the 3 points. The first one is the maintenance, and the second point is quality assurance, and the third one is complex test cases. So first one is maintenance ability of the test scenarios, test cases. So how many test cases we have can be roughly estimated by using the how many Kyua files inside the user tests. And we have 1,000 Kyua file here. So not every Kyua file is connected to test cases, but at least we have one. So we have hundreds or more test scenarios. And those scenarios are written in programming language. Even if a single case is usually very small and easy to understand, but test scenarios usually increase monotonically over time. We do not delete or remove the test scenarios if as long as the standard or specification remains. So the test scenario is, if the test scenario is increasing, the maintenance of the scenario becomes a problem at some point. And 1,000 is not so big number compared to the commercial product and enterprise users. But as a volunteer project, the number of scenarios and the quality of the test cases can be a problem. And written in shell script, written in C program, written in C language, I do not have a serious concern. But written in Python, for example, the Python has a history that the Python syntax is changed at some point of the so version 2 to version 3, or, for example. And in a case, the test case can fail because of the language runtime side, not test success or test failure. So the kind of events occurred frequently. Maintenance of the test framework in a test scenario will be hard. So fixing is not hard, but this is a matter of time, a matter of additional cost in terms of time and manpower. So we tend to be conservative and less dependency in the test framework. It is a general direction we have to take. And the second one is the quality assurance. So testing cases, the testing scenarios are written in the regular programming language, so we can have a bug inside the test program. But we cannot have a test for the test cases because it is so everlasting relationship. So there is no perfect solution, honestly speaking, but we need to be careful. And to be careful, we need to keep the size of the test. Should be test small enough so that we can understand. So we want to have more tests to make the FreeBSD reliable. But we need, at the same time, we need to keep the test suite as small as possible. At the same time, of course, we do not lose the goal of the test. So to mitigate this problem, if someone else develops the test scenario, test framework, we can reuse, we should use it. Because maintaining the test cases, test framework, and the project is not so fun or important. So what we want to do is developing the main part of the operating system. So we do not want to spend more time for testing only, if possible. So considering the leveraging the results from someone else, it'll be good, generally good. And of course, we need to have reliable implementation if we use them as test cases or test framework. But this is a point we have to consider for long-term maintenance. And the third one is the capability of testing. And the complex test cases across the multiple systems are sometimes, so we want this kind of test sometimes, but implementing the test across the multiple systems is pretty difficult. It is not impossible technically, and you can write several shell scripts to invoke the SSH and connect to other machines and feeding the command line into the remote machine and try to establish a connection and then do some testing. It is impossible, but it tends to be not so reliable system and difficult to maintain. And so a good example of this kind of testing is performance testing, especially a networking subsystem. So this slide says the packet forwarding performance testing is one of the example. And of course, we can use the jail or Beehive as a foundation of the packet forwarding testing, but it can test only at functionality part. You cannot do for the performance measuring because virtual environment is just functions on the same machine. So you want to measure the real bare metal performance. You need, say, the 3 nodes and connected by physical wires. So for such setups, QR can handle actually because the QR is just the runtime and the logging reporting part. So as long as you can develop the test scenario binary that supports the multiple system in some way, QR can receive the report. The difficult part is developing the testing binary to realize the performing the test scenario across the multiple system. So there is no consistent framework at this moment, at least on the FreeBSD test suite. Okay, so the problem is these 3 points is not so generic, and it is biased a bit, but let's see that what is being done for these problems in industry. And this is a point in my presentation today. So, and it leads to the introduction of the TTCN3. So TTCN3 is a testing framework mainly used in the industry, so telecommunication industry more specifically. And the TTCN3 is a specification and a standard standardized by the ETSI, Europe Telecommunication Standards Institute, and endorsed by ITU, International Telecommunication Union, and extensively used in so the cell phone protocol and communication between the station and the satellite, or that kind of communication. And the first implementation of TTCN was almost over the 40 years. And at the time, the name was tree and the tabular combined notation. It also it is also the TTCN, but currently that is TTCN stands for the testing and the test control notation. And the name, the tree and the tabular combined notation, is originated from the attitude of standards body, ETSI. The goal is the testing based on the diagram. So usually protocol design is done using some message passing diagram or a specification compiled into the table. So their goal at the time was testing is done by the protocol designer, not software developer. So the protocol designer has a specification in the diagram of the table. So put the information into the computer software called the TTCN. You can get the testing automation by leveraging the software technology. That is the goal. So that is because that is the reason why it was called the tree and the tabular combined notation. But no one understands this as a testing framework, so at some point the name was changed to the testing and test control notation. And the version is updated, but this version was released 25 years ago. So the specification is pretty mature and already used in designing the protocol, new protocol, and testing the actual products for a very long time. And the specification released by ITU tends to be lengthy and very the result of the perfectionism compared to the IETF standard. So mentioned in the third bullet, this specification actually part of the OSI reference model. You already know the 7-layered model of the communication, but these are considered over-engineered concept from people in the ENX world or the internet. But the TTCN3 or TTCN original version was developed to test the kind of complex layered system. So the specification is difficult to understand. I cannot explain everything in 20 minutes or so. So I summarized the things into what we should know before trying to use the TTCN3 software. I will explain in the later slide. First thing you have to understand is that TTCN3 has a lot of things, including the language specification, the runtime specification, interfaces, but the purpose is black box testing. In the telecommunication industry, the implementation details does not matter. So the specification is always specified the communication protocol. So the TTCN test module is defined. It has a knowledge about the protocol, and the communication, and the message exchange. And the system under test, this is a target, is we do not know if this works as designed or not. So the test module is developed first, and this will send a message to system under test first. And the system under test responds based on the specification and the design, and generate the output to pass to test module. And the test module will examine the contents of the output and judge this message passing is correct or not based on the specification. This is a sandbox testing, and all of the communication protocols are tested in this way. So TTCN3 specification is optimized to realize this kind of testing. But you can leverage this specification for other testing because the test architecture is generic enough. And this is on the specification. And there are a lot of elements around the system under test. And the SVT adapter, the platform adapter, and the TTCN executable binary, and the logging, and the codec. And it's pretty difficult to understand. So let's see this architecture by using an example. One of the reasons why I tried to learn the TTCN3 in the first place was I want to modernize the IPv6 protocol conformance testing. IPv6 ready logo was popular 20 years ago. So, and the testing suite was available from the consortium who are interested in the IPv6 standard. But the currently testing suite are not so the organization is not active anymore, and testing suite are available in a permissive license, but the implementation is terrible. It depends on the hardware access, and so it's not portable. And for multiple system, testing for involving the multiple systems, so it uses the serial console access. And inside the test suite, the device node is hard-coded. And so you have to reproduce the test environment carefully by reading the inside of the test scenario and the test cases. So very old. So it depends on the platform, and the FreeBSD can be FreeBSD was usable, but at some point, so Linux is used, and the device node name is totally different. And so I used the test suite by patching to support the FreeBSD for some time. But yeah, internal structure is too platform specific and difficult to maintain. So I gave so another. So I've heard that TTCN3 is currently used in the cell phone industry, even for the IPv6 protocol conformance testing. So that was the reason why I tried this system. So in the case of IPv6 protocol conformance, this is a more concrete goal. That diagram can be rewritten in this way. And a system under test is, of course, a FreeBSD system. And SUT adapter, the platform adapter located just above the system under test, can be interpreted as Ethernet driver and OS service such as timer. And the test program corresponding to binary generated by the Kyua framework we are using is metal boxes on the bottom side of the diagram. So test program you wrote here. This is binary. You can think this is a single binary. But this single binary cannot communicate the system under test directly because this program does not know how to communicate to operating system. So if your program wants to send a packet, the Ethernet frame is generated by this inside this binary. But sending the frame to operating system is down in another software components. In the actual implementation, this part, between your program and the operating system, the Ethernet driver on OS, this part is implemented as just a library. So your program must call a specific function to send a message to FreeBSD. That is depicted by using arrows here. So test program can send something to operating system via this layer, and your program can receive the information from the operating system via this layer. And another layer is located on the right-hand side, and it says the OS service like a timer. And your program may want to use the timer facility to arrange the packet sending in a time axis, for example, to check if the timeout is working as designed or not according to the protocol specification. But your binary is independent from the operating system, so you cannot use the OS service directly. So you need the OS-dependent library and the OS service, such as timer, this software component is that. In the TTCN3 specification, carefully separate OS-dependent part and communication between your program, test program, and the system under test in this way. And the interface between your program and other components are specified as a TTCN3 specification. So this part, this line, is named the runtime interface. And this line is called the control interface. So in practice, you will have a program here, and this program uses the two application interface to communicate to the system under test and operating system that the test binary runs, and the report must be sent back to the controller of the test framework. And that communication will be done using the logging function, and then all of the results will be sent to the runtime toolchain. And if you want to the testing across the lot of machines at the same time or in order, you want to change the parameters, say the IP address or some testing number. In that case, you can use the parameter file and passed from the runtime to the chain. So the runtime to the chain is responsible for invoking your program. That might be on the same machine, or that might be a different machine. But this tool will be responsible for that. And parameter file, the configuration file, will be distributed via the control interface. So you do not need to implement a part that reads the configuration file. You do not need to consider about what format or what parameters are passed in your program. All of the facilities are defined as specification. And in practice, as I mentioned already, these components are not physically separated. It is just a collection of functions in the C program level. So the implementation, there are a lot of implementation of the TTCN3, but fortunately, we have the open source implementation. Implementing the ITU endorsed or ITU designed specification is usually pretty difficult because specification is pretty large. But fortunately, TTCN3 implementation is maintained by the commercial company, the Ericsson, and it is maintained in Eclipse foundation. So, and a lot of telecommunication industry, the commercial companies are using this, and they have own implementation. And I committed the ports yesterday as a develop Eclipse Titan. So if you're interested in, you can install this and try on your box, because it is not so big program. And I will show the example later. And you can run the simple test case on your box. And this program is pretty portable. And when I look into the source code, it says the FreeBSD is natively supported in the first place. And keyword like Linux, Wallis, and Cygwin you can find. And probably a developer 25 years ago, the Solaris was used in the commercial commercial product, and the FreeBSD was one of the cheaper alternative inside the company, I guess. But I don't know the precise. I don't know the reason precisely, but probably the FreeBSD was actively used at the time. But so supporting this program, the porting of this program is pretty easy if the system is POSIX compliant. So, so the reason why I introduced TTCN 3 is it looks interesting. It looks useful even for the operating system testing. So let's see the pros and cons, disadvantage and disadvantage when we use this as a framework for OS testing. First advantage is that this framework is very flexible, and we can use this to build a very small testing case, and using the same framework to build the large scale involving the multiple systems testing in a consistent way. And the technology used inside the Eclipse Titan is very old-fashioned, honestly speaking, in the 90s technology. So I will explain the details of the inside structure in the later slide. But the advantage is a consistent framework and highly modularized. So you can write the very small test in a big module, or you can split everything into the several parts. And the reliability is proven by the commercial usage of this framework. And the disadvantage is the TTCN 3 is another domain-specific language. And it's similar to C or C++, but you have to learn how to write the TTCN 3 language. And the operating system interface, I will explain the details, but the interface between your testing program and the system auto test part must be implemented separately, because operating system specific part is not a part of a TTCN specification. So interface is defined, but if we want to use the, if we want to send a packet from the FreeBSD interface, the TTCN 3 does not know anything about the structure of the operating system side. So you have to write the interface using the API of the TTCN 3. So we have to teach our OS to TTCN 3. So, so to implement that, the OS interface requires the C++ implementation. So that is two parts are probably a disadvantage, because they require additional engineering effort. But the the big advantage is already available industry standard conformance testing can be reused. And this is test suite listed on the ETSI website. So you can see the cell phone protocol that is not so attractive for us, but the IP multicast or IPv6 or so TCP/IP protocol suite are also supported. So you can reuse the library. You can reuse them as a library and try to test our network stack or just part of the protocol. And interestingly, someone at Intel tried to implement the TCP testing suite using a TTCN. You can find this on GitHub. And this project is not maintained anymore, but you can see the TTCN implementation of the TCP state machine. And this is independent implementation of the TCP. And if we want to use this to test our network stack, the task we have to do is writing the connecting part from the TTCN3 and FreeBSD's network interface. And there are several ways, and there are some already existing interface implementation, like a socket interface. So we can reuse this on FreeBSD and or other OSs easily. So let's see how it works and how long do I have? 35 already running out. So so give me 5 minutes or 10 minutes to explain how it works. So let's see the Hello World program in the TTCN3. So this is the program listing, the complete program listing of the Hello World program. And this has 2 test cases. So basically, Hello World part is just the left-hand side. But this is one big file is split into the left column and the right column. And you can get this file using this file name plus this URL. So you can concatenate the FreeBSD slash the first half of this URL, and you can use this file name. You can get the TTCN file. And okay, so let me explain what this means. First, the module is a basic unit for the TTCN3. So this corresponds to file. So this file is named the Hello World. This is the module. Everything is inside the module. And you can define the ports and the components and the test case. But it's difficult to understand using this, but so I can explain this in the diagram. Hello World test cases designed using this diagram. So this is familiar, much familiar for the protocol designer. The purpose is just send the Hello World string to system out test. The system out test will emit the Hello World string on the screen. To do that, the test component must be defined first. This is the central part of the test. And the test part, this component must be capable to send a message to the system out test. So the communication channel must be established. This is called port, and the name the myPCO this in its implementation. So MTC type is just a name, component name. You do not need to care about the meaning of the MTC type. This is just a label. And the components is defined, and the port is defined. The port must be connected, and the system under test will receive the message from the component over this line. This is the basic structure. And in the program listing, the port is defined here. PCO type port is defined here. And inside the definition, what kind of data will be transferred. First string means a 7-bit the alphabet string. And the second type component statement defines the component. This is the central part of the communication. And the component has a port, and the PCO type is defined here. So port PCO type is defined inside the component, and my PCO is the name of the port. A single port is defined here. And you have a port and you have components right now. So you can define the test case. The test case is the execution unit that what kind of test you want to do. And the test case is always associated with the component. So test case, the hello world, this is just a label, and it runs on MCT type. This declaration means that this test case depends on this component. And inside the test case block, first thing is mapping or connecting the two ports. Because the declaration of the port does not mean anything about the connection. So this connection, the component and system under test, these two must be connected. So this connection is done using the map statement. And the MTC means test controller, and the system means the system under test. So my PCO is connected to between the two nodes, one on the system side, one on the controller side. And then you can send the using my PCO the string hello world, this send method. So these two statements will realize the communication from the test component to system under test. That is done. And the last one is the test case must have result. And in the TTCN 3 specification, the result is named the verdict. And the set verdict means the set of results, the pass, fail, error, or in conclusion. These four states can be set. And hello world example does not use the response from system under test. So just after sending the message, the test automatically succeed. So just calling a set verdict pass. This is a single test case. And this list has another test case here, hello world 2. This uses a response. But before going to that, let's see the real execution. So the hello world, this is the hello world binary generated by TTCN 2 chain. And if you run this binary, the test runs, and the first hello world is printed out, and then the hello world 2 test case is run. And at the end of the test execution, 2 test cases were executed, overall verdict is pass. So this kind of report is automatically generated, and you can get this report in JSON or XML, or depending on the configuration. But what you will get is just a single binary. And the dependency is something like this. User local, so third-party software used in TTCN3 is just the XML library. Other than that, almost all of the libraries are just ones in the base system. So you can copy the binary to another system. As long as you have XML library, you can run the same test scenario. You can reuse the same test scenario safely on the same version of FreeBSD. So the time is running out, so I will skip some slides. And I mentioned the OS adapting part must be implemented. So in this program, there is nothing about how the system handles the hello world string. The execution example I showed on the terminal screen, the hello world, you could see a hello world string, but this program does not say anything about the sent message, hello world, will be handled. That part is implemented as a PCO type port definition. And that definition is not included in the TTCN 3 source. So you have to define the PCO type independently. So PCO type must be implemented in the C++ language. So Eclipse Titan toolchain will generate a skeleton to implement the adapter. So you will have a PCO type.cc, and there are predefined method, and the contents are empty. So you have to put the statements or functions depending on your platform or operating system. And in the example, in the table I showed in the previous slide, implements the receiving side, the event handler part is implemented like this. Just a get C to the standard in, and the input data will be sent by using the incoming message library function. This is the API provided by the TTCN 3. So so you can enter some string on the screen, the terminal. It will be sent to the TTCN test binary using this method. So the standard out, the standard in can be used by defining the behavior of the ports. And it is called the operating system adapter. And in the previous example shows the test running on the same machine, but you can split the test controller and where the test actually runs. So the machine A has the same structure of the same component of the test, hello world test, but this test is controlled by another test component on another machine. So in this, that configuration you can understand by using this diagram. And the machine B side is the main test component, and the controlling part, the logging part. And the testing is done in a separate machine, and the communication between the two elements. This is called a parallel mode, and the TTCN 3, the Titan implementation supports the parallel mode and single mode. And the parallel mode can be extended to not only 2, so you can have multiple testing nodes. And the parallel mode, the single mode is switched using the build options. And if you build the binary using the parallel mode, invoking the hello world shows how to use this binary. And you have to specify the main controller to connect the to realize the different location of the controller. So in parallel mode, the above part is called the host controller, and the below part is main test control component, the MTC. So MC and the HC is separated, and your built binary will work as the host controller, HC. And the main controller can be set up using the mctl CLI command, and the configuration file can be prepared to control the host controller. So in this example, host controller have a hello world.cfg configuration file, and the contents is something like this: logging and execution and the main controller TCP port or something like that. And this configuration parameters will be sent over TCP connection to all of the host controllers remotely. So you do not need. So what you need is to copy the binary, hello world binary, to target system, and set up the main controller and run the host controller on the remote side. To do that, by doing that, the TCP connection is automatically established between the host controller and the main controller, and these parameters will send over the control channel, and the test scenarios runs on the remote side. And all of the results will be automatically sent back to the main controller. And the information will be recorded into the log file. Okay, so time is running out. So the summary of structure can be like this. So in short, this is a 90s technology, like Sun RPC Gen, because compilation of the TTCN file is actually a translation of TTCN file into the C++ program. And the compilation is done using the C++ compiler, actually. And this translation adds the necessary components to your program. I explained in the big diagram, and there are a lot of libraries around your program. And the library part is put into a single C++ program, and then the testing binary is generated. That is the reason why there is no dependency. And the runtime environment is it has two modes. One is a single one, and another is a parallel one. You can have a main controller to orchestrate the testing environment, and agent, the host controller side, can be realized using the same binary. So if you want to try the TTCN toolchain, what you have to do is download or install the Eclipse Titan using the FreeBSD ports, and write a TTCN file. And the hello world file is available on the same URL, so you can try to run the testing scenario using your FreeBSD environment. But the advantage is that there are a lot of libraries available for various protocols already. So TTCN3 is not a simple system compared to the QR plus the shell script test cases. But if we seriously consider to do the perform the conformance testing on the network protocol, or the kind of state machine related interaction, TTCN3 is a good foundation to implement the test case. And so I mentioned that the OS connecting part is not so rich and not so good in the implementation of the Eclipse Titan at least. But the TCP socket interface and the pipe connection and the standard in, standard out, these kind of interface are available. So we use this kind of implementation and try to implement the message passing between the server and the client of the internet service. And the porting noise is listed. So Eclipse Titan depends on the GNU toolchain, the GCC and the GNU Make and Bash. And this is not so strict or problematic because GCC dependency is not so strong. And someone in the Linux world is trying to support the Clang. So, probably support will be added to the upstream. And Gmake and Bash dependency is not intentionally added because the Titan implementation used to support the Solus, and the Solus Make works with the Titan implementation. So, but the recent move from the various Make implementation to the Gmake, probably most of the developers thinks Make is just a Gmake only. So that was the reason why the recent Titan version has some GNU Make dependency. But I am working on removing the Gmake dependency and plan to upstream to the changes, upstreaming the changes too. Okay, so this is almost the last slide, future directions. And I introduced a testing framework, Eclipse Titan, and it is a mature implementation. So it is not the replacement of what we are using, but I think this is another tool chain we can use even for the operating system testing. And I am currently working on the performance testing on a multiple physical system because I try to implement the so packet forwarding performance testing using a 3 noise with 40 gig NIC at some point at some data center. But I build using a shell script or some lightweight language. But it works, but it is really difficult to maintain. And so if I maintain this, I maintain the testing framework by myself, it is possible. But if someone must maintain or someone must use without knowing the internal structure, it is difficult to explain, and it takes a long time for me to teach how to maintain. So I want some more generic or more standard way or consistent way to implement that kind of testing. So performance testing is one of the good candidates. And in addition to that, I'm implementing the standard conformance testing because the standard conformance testing, like the POSIX standard, it involves a very big testing suite. So I'm trying to adopt that kind of large-scale testing into the TTCN suite. Okay, so the other elements in the bullet list just say my impression about the current possibility to replace the current test cases in the base system. First one is yes, TTCN3 is flexible enough to implement very simple test cases that consists of simple command line invocation. But replacing them with the TTCN module is kind of overkill. I agree with that. But if it requires multiple system, it is still worth using. So I think the TTCN is one of the options, even for our testing framework. And the last one is I'm still wondering if we can use this framework to protocol testing. And currently, some test cases to send the raw packet using the Python, the escapee or something like that. Probably Christoph has some test cases. And it is good and working. And I do not insist to replace the escapee with the other system. But if we can easily use this framework, and if we find something useful, this kind of test can be implemented into using this TTCN3. Okay, this is the last slide, references. If you are interested in, please visit these sites. And but probably first thing you have to do is get a big picture about TTCN3. I put information into my slides, but it is not enough to understand how the TTCN3 works. So I recommend to read last one, the book, first to get the purpose of the TTCN3 or history and the goal of this testing framework. Okay, that's all. Sorry for the long time, but that's all today. Okay, questions?
I guess you're continuing to work on this and
yep.
trying to adapt some tests for
yep.
FreeBSD. Do you
yep.
have some specific stuff in mind?
I'm sorry, on specific what?
Do you have specific stuff in mind, specific tests that you would like?
I want to implement some IPv6 related tests, like sending an array and receiving the so NTP part I'm considering right now. So it requires raw packets and raw packet receive to check the kernel behavior, including the kernel behavior. So yeah, that can be done in the escapee, of course, but there is no protocol testing. So wire level packet exchange testing is not included in the current user test. So that is a target in my mind right now.
Can you use multiple devices under test? Or, for example, if I want to do IPsec or OpenVPN regression test, I need 2 IPsec routers to set up on 1 packet generator and 1 packet receiver, so 4 physical machines. Can you use that for?
So repeat, yeah.
Yes. Can you use? Okay, I saw in your slide that you can remotely configure 1 device under test, but if I need to configure 4,
you can use the multiple system under test, because just you can define the multiple component, the multiple ports. So there is no restriction about the number of ports and the noise. So in this case, it's just a user under system under test is here, but you can define another ports, and you can have another system user test. And it is not always to be static configuration. You can dynamically change the configuration depending on the packet exchange, for example. It is very flexible system.
So I was recently testing FreeBSD for conformance against a couple RFCs, network stack specifically.
Mm-hmm.
And when we were testing, we were using Exia box. It's an external traffic generator,
Mhm.
and it SSHs into the machine and runs some commands to invoke sorting protocols. And so, how would you say TTCN tree would give us advantage if we were to adapt it? What kind of advantages it would have, or what kind of disadvantages? Is if we decide to not use an external traffic generator, but use a TTCN tree to test UDP, NDP?
If you want to have so packet generator as an input, using a TTCN3, there is no way to prepare such a data or using this framework to generate the input data directly. So you still have to have a packet generator if you want to do the so performance testing using the violate testing or something like that. So there is no special instrument inside the framework, unfortunately.
But for tests that are not related to generating a packet, such as the HCP or ARP, we are still using the external box. And
but the protocol-specific exchange is defined. Not if you do not need any performance thing. The predefined packet generation routine is provided as a library, so it is proven according to the commercial company. So they are using the reference packet exchange using so they have a library for that. So you can rely on the library to generate the IRC compliant input and output.
So if we were to use TTCN3 for this,
yes,
instead of a packet generation, what kind of advantages would we see?
So you do not need an external packet generator in that case, and you will have the more flexibility using a TTCN3. For example, you can design the test scenario using the more dynamic case. So, for example, the DHCP has a lot of states, and so state transition can be designed inside the TTCN TTCN language in your program, so freely. So using an external packet generator, you can use it as a unit testing or a very small part of the state transition. But in the software implementation, you will have a more flexibility. So that is so advantage of using this kind of framework, I think.
Good, thank you.
Okay, thank you.